Hello, calculus fans. Let's describe the region that's above the cone, z squared equals x squared plus y squared, but below the sphere, x squared plus y squared plus z squared equals 9. This thing looks like an ice cream cone. Here's a picture. So you see the cone, you see the sphere. We're going above the cone, but below the sphere. It's like an ice cream cone. Let's describe this ice cream cone in spherical coordinates. And what you're going to find is that it has a very nice description in spherical coordinates. Let's take the equation z squared equals x squared plus y squared, and we'll substitute in the spherical coordinates conversion formulas. We want to get an idea of what the cone looks like in spherical coordinates. Okay, we've got z squared equals x squared plus y squared. We substitute in x equals rho sine phi cosine theta, y equals rho sine phi sine theta, and z equals rho cosine phi. Let's do a little simplification. Notice that on the right side we can factor out rho squared sine squared phi. And then we have in brackets cosine squared theta plus sine squared theta. Well, we know what to do with that. So we end up with rho squared cosine squared phi equals rho squared sine squared phi. Nice looking equation. So that really tells us that cosine phi is equal to sine phi. So here we go, a nice, really simple equation that describes the cone. Phi equals pi over 4. That's an equation that describes the cone, at least the top half of the cone, which is what we're dealing with here. Now the angles for phi always start at 0. That's the positive z-axis. And the angles for theta, they simply go all the way around. Like in polar coordinates, if you have a disk centered at the origin, then the values of theta go all the way from 0 to 2 pi. And finally, rho starts at 0. That's at the origin. If rho is equal to 0, you're at the origin. And ends at 3. That's on the sphere. So, we put all this together and get a very easy description of this region. Our ice cream cone looks like the set of all points, rho, theta, and phi, where rho is between 0 and 3, theta is between 0 and 2 pi, and phi is between 0 and pi over 4. That's a nice description of this region. In a sense, this is like a rectangular brick in spherical coordinates. That concept will be very important as we move along and do some more advanced problems. Okay, that's all for now.